Hi everybody, this is Oliver Schulte, instructor from Database Management Systems 354. I'm recording some comments on Tuesday's lecture, the one before the midterm. Sorry I can't be there. I accepted an invitation to give a tutorial on machine learning for relational databases at the Canadian Conference on Artificial Intelligence. So at least it's about databases. So our plan is that I will record these comments and then Zensong will go through them with you. That should take us about 2 hours, maybe less, and then there should be about an hour left to answer questions about the midterm, review the material, answer questions about the assignment. So Zensong will do that with you. Zensong is one of my PhD students, very knowledgeable about databases. He's been a TA for 354. He's also worked for SAP. And if you're nice to him, he will tell you what it's like to be doing databases at SAP. Okay, so let's get to the overview. The topics that we're going to discuss today are null values, security and access control databases, and integrity constraints. But before we do that, let's do a brief review on aggregate functions, which was our topic from last time. Here's two true or false questions. In an aggregate query, is the where clause applied before the aggregate function is evaluated or after? The other question is, in an aggregate query, the where clause is applied before the having clause is evaluated or after? Okay, so think about that, then we'll have a show of hands who thinks, which of these questions has the answer true or false, and then some will tell you what the right answer is. Okay. Alright, so first topic are null values that are very useful, but also kind of tricky to use. So when do we use null values? Well, one example is for unknown values that we just haven't recorded. So we saw in the sailors table the example where Sailor Dustin just does not have a rating recorded. A value may also be inapplicable. So suppose we have a field for a spouse's name and the person is not married. Or we have a field for a driver's license ID and the person does not have a driver's license. And finally, we may want to not record the value for privacy reasons. Maybe it's someone's phone number, someone's login, so it may be perfectly applicable, it may even be known, but we just don't choose not to enter it. We also saw in the Mondial database many examples of null values. So having null values gives rise to a whole set of new issues. One is checking to see whether a value is in fact null. So we'll see that we need special keywords just to say that, and we'll see why in a bit. We have to talk about evaluating expressions when you have null values. So for example, if you have a null rating and I ask you, is that null rating greater than 8? Is that comparison true or false? And it gets even more complicated when these comparisons can involve Boolean connectives. So for example, rating greater than 8 and age equals 18. So should that be true or false if the rating is null? And finally, the key question is ultimately how this affects our queries. So if I have a query, say with a where clause where rating is greater than 8 and rating value is null, should I then return the tuple for which the rating value is null or not? So the first thing to note is that although null in many ways is like a constant, for example, it's something that we can enter in a cell in a database, it really is fundamentally different from things like green or the number 3. Okay. And in particular, we have special rules for null values. Basically, if you try to do any sort of operation on null, you get null back. So if you say, for example, 3 plus 4 plus null, that would give you null. The answer would be null. And when you try to do a comparison with null values, you get a new truth value called unknown. So in the example I gave, if the rating is null and you say, is rating greater than 8, so is null greater than 8, that's neither true nor false, but that gets treated as unknown in SQL. And the key thing to remember is that when you have a query, it returns only tuples where the where clause comes out true. So of course it doesn't return tuples where the where clause comes out false, but it's also the case that if the where clause comes out unknown, the tuples aren't returned. So if I say, for example, select star from all sailors where rating is greater than 8, if the rating is null for a sailor, that sailor will not be returned. So let's see, maybe then someone can have a little demo with that if it's not clear. So now we have to think about the meaning of Boolean connectives with unknown truth values. This is in fact a traditional topic in logic called three-valued logic. It's been discussed by logicians since at least the 1920s. And I'll give you some of the rules that SQL uses for handling unknown truth values, and then we can discuss why they make sense, and I'll give you a couple of ways to remember why they, a couple of ways to remember how they work. So looking at the bottom here, let's look at the rules first of all. True and unknown evaluates to unknown. Okay. False and unknown evaluates to false. So if I have a condition where the first condition is false, the second is unknown, and I put them together in a conjunction, I get false. If I have false or unknown, I get unknown, and not unknown is unknown. So let's think about why those make sense. So one way to think about them, at least some of these, is in terms of lazy valuation. So let's look at this one, for example, false and unknown. Well, if I have a condition that's false and I say something that's false and something else, the result is guaranteed to be false, right? So if I say the age is greater than 60 and the rating is 8, and you tell me that the age is in fact 50, well then I already know that the comparison is going to come out false regardless of the other value. In the other cases, you can see that that lazy valuation strategy does in fact not work, right? So for example, for the first clause here, true and unknown, that could come out false, right? So if the second condition is turns out to be false, then the whole conjunction is false. So basically, one way to think of what SQL does is it applies this lazy valuation strategy. So if it has enough information to conclude for certain what the outcome of the comparison is, like in the second case with false and unknown, then it returns what it can conclude, false, for instance. And if it doesn't have enough information to be certain about what the outcome is, it returns unknown. So what do you think you would get if you had true or unknown? Let me see if I can write that. True or, let's just call this UK. Okay, so ask Zensong for the answer, and this might be a cause for discussion. So this logic is known as Kleene three-valued logic, after the great American logician Stephen Kleene. One way to remember it that you might find easier than just memorizing the rules is if you think of true as being corresponding to 1, false corresponding to 0, then you can think of unknown as corresponding to a half. So that makes sense, right? Unknown is like between true and false. And so now you can generalize the usual rules. So if you think about ones and zeros, and takes the max, right? So for example, 1 and, sorry, I should have said and takes the minimum. So for example, 1 and 0 gives you 0. Or takes the maximum. So for example, 1 or 0 gives you 1. And not gives you 1 minus your truth value. So not 1 is 1 minus 1, which is 0. Okay, so that means not true evaluates as false. Okay, so if we apply that to our various cases down here, here's what we get. Let's say, let me get rid of this first. Let's say we're looking at true or unknown again. So this one. So true is 1. Unknown is a half. I need to center pen here. 1 over 2. And so and says that we take the max, the min. I made that mistake again. So the min is a half, right? 1 min and a half. The minimum is a half. So we get back the answer a half as the minimum. And let's see where else. Let's do maybe one more example here at the bottom. Let's say if we're talking about negation here, we have 1 minus a half, so that's equal to a half. Okay, so I hope that makes sense. Now let's go see how we can apply that. So let's think about this query. Select everything from sailors where the rating is less than 5 or the rating is greater than or equal to 5. So before today's lecture, you might have thought, oh, that's going to give me all the sailors. But in fact, that's not necessarily true, because if you have a sailor with a null value, let's see how that evaluates. So rating less than 5 is a comparison. So null less than 5 is unknown. Okay. Rating greater than or equal to 5 is also unknown, because we're comparing a null value. And then when we do unknown or unknown, if you think of lazy evaluation, well, they could both be false. Or if you think of our half rule, that's the max of a half and a half, which is a half. So this or also evaluates to unknown. And so that means that for a sailor whose rating value is null, the where clause evaluates to unknown, and SQL does not return a sailor who whose where clause evaluates to unknown. It returns only the tuples that whose where clause evaluates to true. Okay, so you can check that for yourself by running the query in the sailors table. Okay, but that is a tricky thing to watch out for. This is easy to screw up in queries if you're not thinking about null values. You may think something like, oh, if it's greater than 5 or less than or equal to 5, it has to be selected, but it actually doesn't. Okay, so let's illustrate how tricky things can get. Look at this query that's shown here. This one. So select everything from the sailors where the rating is less than 5 or greater than or equal to 5. And you might think, well, that's going to get all the sailors. But suppose you have a sailor whose rating is null, like in the Dustin example that we've seen before. So then the null rating less than 5, when that's evaluated, it comes out as unknown, because null less than 5 is unknown. Or null rating greater than or equal 5 also comes out as unknown, okay, because null greater than or equal 5 is unknown. So now we have unknown or unknown. So if you apply the rule that we just learned, that's the same as saying minimum of a half and a half. So that will give you a half, also unknown. So unknown or unknown is unknown. So that means that the whole where clause evaluates to unknown. Okay, the whole thing. And so the way SQL works is if a where clause evaluates as unknown, it does not return the tuple. So in this case, it would not return Dustin having a rating of null. SQL returns only tuples where the where clause evaluates as true. So that would be an easy mistake to make. And it's an example of how you have to watch out if you don't think about null values, but you do have them in your data, then your queries may not behave the way that you expect. So the next topic is how we can use null values to address a problem that often arises with joins. And so when you use null values in combination with joins like that, it's called an outer join. So what happens in a join is that you're taking the cross product of two tables, filtering by a condition, and often you have some tuples in one table that don't match tuples in the other table. So for example, if you had sailors who've never reserved a boat, then when you join sailors and reserves, those sailors will just be lost. And in some applications, you don't want to lose those sailors. Okay? You may want to include them in the result of your query, together with the information that they haven't reserved any boats, but you may not want them to disappear altogether. So let's look at another example. So let's see here, let's not worry too much about the exact meaning of left for now, But suppose that we want to join together the employee table and the department table. And what we want to do is we want to match the employee department ID with the department ID for that department. So for example, if you look at Rafferty here, we've got ID 31 and we want to match that with this ID 31. Okay, so now what will happen if we take someone like John now? And it so happens that John here failed to have a department recorded. Maybe he doesn't work for a department, maybe he's doing his own thing. And so now if we join this table, we will lose John. But the intention really of the person who wrote this query was to say, well, just list all the employees and for each employee list their department. But that would fail because John isn't listed. So what we do is we use a left outer join, and the result of that is that all the employees from the left table, so the left table being the employee table, if they fail to match with a tuple on the right table, being the department table, then they will nonetheless be included, and the values that should have come from the department table will be set to null. So that's exactly what you can see happening for John here. One other comment, if you don't, we did review this, but if you don't remember the join notation, so employee join department on some condition is the same as saying from employee, department where the condition holds. So the join on syntax is equivalent to the theta join in relational algebra. Okay. Now why did we call this left outer join? Well, because we said all the tuples from the left table should be preserved in the outer join. As you probably guessed, we can also have a right outer join where the preservation is the other way around. So now we say take all the tables from the right, take all the tuples from the right table, and if they fail to be matched with anything in the left table, then include them as null values. So in the example, if again your intention is to list for every employee their department, and there's a department that just happens not to have any employees in it, like marketing, then instead of just losing the marketing department, the right outer join will include a tuple for it, and and then the employee information will just be set to null, which makes sense because marketing doesn't have any employee. And I just see now that the green circle here, that this should have been around this tuple here, so sorry about that. Okay, so can the left join replace the right join? Here's a think question. I'll give you a bit of time to think about that. Well, the answer is yes, you just need to change the order of the tables. So you can go to a situation where you want tuples included from both tables, okay, and that's called a full outer join. So in this case, oh, again, that's messed up. But so if you change the syntax to be perform a full outer join of employee and department on both of them, on both tables, so then on the right, the marketing will be included here. Okay. And on the left, John will be included here with null values. Okay. Sorry about the slides being messed up. So that's it for outer joins. Okay, again, so the main idea is that if you have a tuple that happens not to have any matches in the other table, then you include that tuple together with null values. Hey, by the way, there's an SQL joke about joins. I think this is my last chance to tell it. So an SQL query walks into a bar and sees two tables. He walks up to them and says, "Can I join you?" Good joke, huh? Sorry I'm not there to see all the laughter. Our next topic is security in SQL, how to manage user access as a database administrator. So access management is familiar from file systems like Unix. You can, for example, for a given file, you can decide who gets to read it, who gets to write it, who gets to execute it. You might want all your friends to read your assignment, but you may not want them to be able to execute it. And in the database management system, you have similar options with similar levels of access. But in this case, it's not files that we're controlling, but tables and also views. So, for example, in our SQL server setup in Sysl, all 354 users are allowed to execute a select on tables such as Star Wars and the Adventure Works. Okay, so that means in file system terms that they have read access, but they are not allowed to delete records or even create tables. So a 354 user cannot execute the counterpart of write operations in our shared databases, right? And it's obvious why, so that nobody messes up our shared tables. Okay, so there we have read access and no write access. That access, and the main keyword here to remember is grant. Okay. So the syntax basically says grant, and now access to the kind of commands that you want the user to do. So for example, if you want the user to be able to insert or delete, you say grant insert or delete, and then you say what table that privilege should apply to. So let's say it's reserves in our Sailor example. And then Yuppie would be the user. Okay, so grant, say, insert privileges on the reserves table to the user Yuppie. So now Yuppie can insert into and also delete from the reserves table because we specified delete here. And what else? And what the with grant option, that's an interesting SQL concept. This means that Yuppie can also give these privileges to others. Okay? So there's privileges that a user can have for themselves, and then there's the privilege of assigning privileges for others. It's like a meta privilege. Okay? So if we say with grant option, as we did in this query, then that means that Yappy could then himself execute a grant query, for example, grant insert on reserves to Dustin. He would have the right to pass on the right of inserting. Okay. Let's see. Stuff. The combination of views and access rights can be very powerful. So suppose we create a view called Young Active Students, which records the names of grades of students who are enrolled in some course and who are younger than 21. Okay, and then for each course, this view will show their grade. And so I can create a view, and as always, I can create a view I can treat a view like a table. So I can now say grant select on young active students to Michael. And now Michael will have the right to view information about students meeting the query. And the great thing about this is that I can do that without giving Michael even read access to the original data tables. So even though Michael can now see some of the names and some of their grades from the view, that doesn't mean that he's been granted select access to, say, the students table. Okay, so let's just look at an example again within the context of our CECL framework. Suppose we said use OSchulte 354 or your own database. So we go to one of our users' personal database. Then we say go, which is SQL Server's way of starting a script. And then we say create view characters as select star from the characters in our Star Wars database. So what do we have now? Well, we have in effect a copy of the characters database. Okay, so one copy is sitting in the shared Star Wars database. Okay. And the other copy, this one, is sitting in OSchulte 354. Okay. So of these two tables, we have different access privileges. So OSchulte has create permission on this table here. Okay. And for example, OSchulte could have selected only some of the columns in that table. Okay. Or OSchulte can change, rename columns, maybe drop rows. On the other hand, for the other database, the shared database, OSchulte has only read access. Okay, so that's it for SQL Grant. I mean, there's more details, but the main thing to remember is that SQL gives you easy to use and flexible ways to assign different levels of access and privileges to different users. Including the option of passing on the privilege, paying it forward as it were, by using the with grant option command. Now we come to the major topic of this lecture today, integrity constraints. And we're going to look at three constructs that SQL offers for enforcing integrity constraints that we haven't seen so far: check, assertion, and triggers. So we'll start with check and assertion. So integrity constraints, just a reminder, describe conditions that every legal instance of a relation must satisfy. For example, a name has to be a string, age must be less than 200. So we want to catch data entry errors, and we want to make sure that the data we record are faithful to the intended application domain. Sometimes they're annoying. For example, on US websites, they sometimes enforce the constraint that a zip code has to be purely numeric. So then if you're a Canadian and you're trying to enter your address and you've got a alphanumeric postal code like V5A, then 016, 1S, I guess, then the database system says that's not a legal postal code, and you want to say yes it is. But anyway, so generally we want to have the capability of enforcing integrity constraints. So we've seen domain constraints, primary key, foreign key constraints, and those are quite general constraints. And now we're going to look at constraints that go beyond that can be of any nature, okay, or at least of a much more general nature than the ones than say foreign key constraints. And the two concepts we'll look at is check and assertion. The idea of check is that as part of the creation of a table, part of the definition of a table, you basically write an SQL query that specifies a condition that should be true, and then SQL will say, oh, okay, as I'm maintaining this table, I have to always check this condition and make sure that it's true. Okay? And this idea comes in two varieties. You can have a check associated with an attribute, like say rating, or you can have a check associated with a tuple, like let's say the entire sailor's tuple. I'll give an example in a minute. And assertion will be a general statement, again typically in the form of an SQL query that you want to be true, and in principle, an assertion is an object in its own right, so independent of any particular table, and usually that's what you use when you want to combine constraints from different tables. Okay, so let's look at some examples of these. So an attribute-based check is checked whenever a tuple gets a new value, so basically whenever an insert or update happens. Okay, and if you violate the check constraint, the update is rejected. And in principle, meaning as far as the official SQL standard is concerned, a check constraint can contain an SQL query that refers to other attributes. So even though you may be imposing the constraint on, say, the rating attribute, you could be relating that to age. Okay. And the consequence of associating a check constraint with an attribute, like let's say rating, is that if other attributes are updated, then it doesn't check, the system won't check the other attributes. The most common application of this thing is actually to check a range of values. So let's say if you know that ratings are between 1 and 10, you can write a check constraint that says, okay, they have to be in that range. If you know that grades have to be A, B, C, D, F, then you can write a check constraint that ensures that. So you can use it to do something like custom data types. Okay, so let's look at some examples. So at the top here, you see what I just mentioned, where you create a table, you set up a primary key, and then you have the check constraint here. Oops, that didn't work. Alright, let me just use lines. Check constraint here. Okay, and so this is associated with a rating, so that will ensure that every time the rating is updated, the system enforces it to be between 1 and 10. So notice the form of this. This is an SQL query, right? Something that, and it's a Boolean query, something that could appear in a where clause, and it uses the rating attribute. So rating here, rating here. At the bottom, you see a more complex constraint, so maybe we should take a bit of time and think about what this might be doing. So check interlake not equal to this query. So maybe I'll let you think about that for a few seconds. Okay, so maybe feel free to discuss it, but what this does is it ensures that no tuple entered in the reserves table has interlake as the name of the boat. So, or less formally, it ensures that the boat named Interlake is never reserved by anyone. Okay, so now I know you're getting excited about these wonderful check constraints and this powerful ability to simply express constraints using SQL query. So before you get too excited, let me just mention that in practice, most systems don't actually support this type of thing. So if you look at the first constraint, this one, check rating, that works in SQL Server. In MySQL, it's valid syntax, but it's just ignored. So you can define it, but it won't actually enforce it. This one, number 2, again, perfectly valid syntax in principle, but even in SQL Server, it won't be allowed. Basically, they say that you cannot have a query in a check constraint, so they wouldn't let you write something like select. So it's kind of a more theoretical concept, which is one of the reasons why we don't go into it so deeply in this course. So another variant on the idea of combining check with SQL queries is what's called a tuple-based check. So if you look at the example below, create table sailors and check that the current rating is greater than the previous rating, where both current rating and previous ratings are attributes in the table. So here we're checking a relationship between two attributes in the same table, right? Namely that the ratings only go up. And so that's why this is called a tuple-based check, because it's not just about a single attribute. And again, we could have a tuple-based check about other tables. Actually, let's skip this slide because we covered this example enough. So let's consider the case where we want to have constraints over multiple relations. So far it's only been about sailors. We might consider something that we want to say about sailors and boats together. So call this a small club idea. If I add the number of boats and the number of sailors, that total number should be 100. Or I might want to have a constraint that says something like you cannot have more than four times the number of sailors per boat because only 4 people fit on each boat, or something like that. Now I could try to write this in the sailors table. I could make a check constraint, and then I could run a query that says select the number of sailors, select the number of boats, and make sure that together they're less than 100. So that's what you're seeing here. By now you should have enough practice with aggregate functions that you can read this pretty easily. But the problem with that is conceptually it's wrong, because it's really a constraint about sailors and boats rather than just sailors. And it doesn't give you good results because it doesn't it only checks things on when the sailors table is updated, So in particular, if there are no sailors tuples to check, then the number of boats won't be checked at all, even if it's 1,000 boats. So the best way to do this is to create what's called an assertion that gets a name, call it small club, and then within that assertion, then you have a check command that is the same query, but now it's a standalone query, a standalone condition that you check independently of any table. So if you have an assertion like that about the sailors and the boats, it will be tested whenever one of the reference tables is modified, in this case sailors and boats, and then it will reject the modification. So for example, if you try to insert 1,000 boats, then that insertion will be rejected. Now, you can already see that assertions are going to be more difficult to implement. Check constraints associated with a single table are more local, so you know that they only need to be checked when that particular table is modified. So if I have a check constraint on sailors and I change the boats table, I know I can ignore the check constraints. Assertions are trickier that way. So let's look at a couple of examples. So here's the one again where we had the number of boats plus number of sailors. Here's another one, a little more sophisticated. Suppose you want to say the number of reservations per sailor is less than 10. You can create an assertion, and then what you do here is you make a table where you group by sailor ID. Okay, so again, this should be familiar, but let's just for review, let's do it one more time. So it's going to look like this, sailor ID, and then you're going to have the count. I'll just write this as C. So you might have sailor 10 has made 20 reservations. Okay. And then you can check actually using the all constraint, you can check quite elegantly and make sure you can say, well, I don't want any, so for every sailor I'm going to find the number of reservations they've made, and I don't want any of those reservation numbers to be greater than 10. So again, but the general point here is that you have the full power of SQL to write assertions, and that allows you to express a lot of constraints. Okay, so now let's get some practice, both with assertions and with SQL queries one more time. And let's look at how we can write some of the constraints using check or assertions. So the first one says employees must make a minimum salary of $1,000. Okay. And the second one is that a manager must always have a higher salary than any employee that he or she manages. May well be true, often true in the real world. And so again, the first question you should ask is, can I make this a constraint on a single table, or does it involve multiple tables? And then depending on that answer, you can choose a check constraint or a assertion. Now, one of the reasons why many actual database management systems don't implement concepts like assertions or queries and check is that they implement a more powerful concept known as trigger. So triggers can do what checks and assertion constraints can do, and they can do even more. So I do want you to know that they exist. They're often very useful. I want you to have a rough idea of how to use them, but I won't put them on the exam. Part of the reason is that they're a bit complicated, and the other reason is that there's really no universally accepted syntax. So when it comes to the question of, for example, how would you write a trigger, then you have to answer, well, do you use the SQL standard, do you use MySQL syntax, do you use SQL server syntax? And so then it's not clear what we want to use.
Okay, but like I said, definitely something worth knowing about. So I will tell you about the basic facts about them now. So what is a trigger? Well, it's a general procedure. Where's my pen here? That starts whenever specified changes occur. So you can think of it roughly as running a program when something happens. Okay? And there are three parts to this. One is the triggering event, the condition that the trigger is looking for. The other is the condition, so which tests whether the trigger should be run. Okay, so you can say run this trigger only for certain circumstances. And then when the event happens and the condition is evaluated as true, then you specify the action that should be taken when the trigger runs. If you want to know more about this in glorious detail, it certainly gets covered under the topic of transaction processing, which I've mentioned is covered in 454. Okay, so there are a number of options that you can specify when you define a trigger, and I'll give you an example for these, but as an overview, one question is, when should the trigger be activated with respect to the statement of interest? So let's say you're inserting a number of sailors in a table and you have a trigger that maybe checks a condition on the inserted sailors. You can set the trigger to be triggered before the insertion happens. You can set it to be triggered after the insertion happens. You could even say instead of an insertion. So if there's some action that you don't want to occur, or some action that you maybe want to modify, or you can even say deferred. So for example, if I was uploading a set of grades for a course, there could be a trigger that says, okay, after all the grades have been uploaded, go through and calculate summary statistics for them. So there's different times when the trigger can be triggered relative to the statement that triggers it. The other main option you have is, let's say, how often you want to activate the trigger. So you could do it once per modified tuple or once per activating statement. So in my grades example, you could say, well, after all the grades have been uploaded, then run the trigger on each grade. Okay? Or you could say, well, just run the trigger once for the whole upload statement. So for example, count the number of A's that have been uploaded. Okay, and I'll give examples. So the referencing clause was mentioned here. We called it referencing new table, and without worrying about what the keywords mean exactly, try to sort of read it as semi-English and try to guess what this thing does. Okay, so if you look at the different pieces, so first of all, when is the trigger triggered? Well, that's specified here. Okay, so after an insertion on sailors. Okay, let's not worry so much about the new sailors now. And then after the insertion, what happens? Well, basically what happens is that this query gets executed. Okay. And what does this query do? Well, it's more or less a standard SQL query. So it inserts into a table called young sailors, this one. And what does it insert into that table? Well, information about the sailors, sailor ID, name, rating, from the new sailors. So the new sailors here are the new ones that have been added. Okay. And it has a filtering condition that says, well, only insert the new sailors that are less than 18. So overall, you can think of this thing as saying, well, when there are sailors inserted, find the young ones and write those young ones to a separate table. And then we might process them further. So maybe the young sailors need extra scrutiny, or maybe a report should be printed saying, okay, find the new sailors. Or perhaps there could even be another trigger that says, oh, if there are any sailors less than 18, then delete them from the sailors table. So that's actually an interesting example, because you can see that you can get cycles, right? You could have a trigger that says, oh, when a new sailors table is inserted, write those records to another table, and then a trigger defined on the young sailors table here might say, oh, delete the records that are in there. And the deletion could in turn cause another trigger to insert new sailors. So one of the problems with triggers is that if you have many of them on your database, they can trigger each other, and it can become difficult to predict what the overall effect is. There are all this cascading writes and updates. In practice, what happens is that database systems restrict what triggers can do quite severely to avoid any of this sort of cycling infinite loops problems. So I will say a bit more about that later. I hope this works in this program. Okay, so one option was new table. That's what we saw. So this will give you the set of tuples that were newly inserted. Old table gives you the tuples that were there previously, for example, the set of deleted ones, or if you did an update where, say, you changed the ratings, it would give you, say, a set of sailors with their old ratings. And old row, new row are the same concept, but based on, for row-based triggers, where you're actually triggering the statement for each row. So this is actually a cool thing about triggers, is that by making what are in essence temporary tables that contain just the modifications, you can now very easily work with the modifications within SQL. Okay, that's basically what the example is that we just saw. Okay, so you don't have to write a Python program that says, well, check the log and see which records are actually new, and write those to a table and then process that table within SQL. The system does all that for you, and then you can treat these new records as if they were a table on the system. So I know the syntax is a bit complicated to get used to, but this is actually very useful, elegant, and really, once you're used to it, quite simple to use. Okay, so let's look at an example, and again, it's worth thinking for a few minutes, well, not minutes, but 1 minute, about what this example does. Okay, let's first look at all the conditions. So we're creating a trigger, and we specify the event, that's here, which is after an insertion happens on reserves. Okay, so somebody has written a query that says insert the following records into reserves, and now it's going to be a row-based trigger, so it's going to go through each new row, okay, and each new tuple, and that new tuple gets a temporary name, namely, and you can choose that name, but call it new reservation, for example. So that's like a range variable. And then this trigger you can do for each row. Okay. And now the trigger is set up to go, we can add even more power by checking a condition first. So that's here, using the when keyword. Okay, so we haven't seen that before. So what does this do? So it says I have a new reservation, right? So sailor number 10 has reserved boat number 100. And what I'm going to do is new reservation.sid now would refer to the 10, right? The reservation of a new sailor. So I can now count how many reservations that sailor has previously. Okay? And I can check if that sailor has more than 10. Okay. Oh, actually, sorry, it's triggered after insert. Sorry, so this is including the new reservation. Okay, so that's what this when condition does. And the when condition says, okay, when that sailor has more than 10 reservations, then do something. So this would be the situation where you want to enforce that sailor should not have more than 10 as a constraint. And then what does it do? That's in the body here. So what it does is it deletes from the reservations. Okay, now it does something somewhat complicated, just so that we can give you a bit more practice with somewhat more complex SQL queries. I mean, it could just say delete from the reservation everything, or delete from the reservation everything that sailor has done. But you can actually say delete the oldest reservation, which makes sense, right? So keep the more recent ones around. And you can do that using one of the aggregate queries of the type that we reviewed before, right? Where we said, for example, find the find the age of the youngest sailor. So more specifically, this subquery here will find the oldest reservation from the reservations made by that sailor. So notice the correlation here. Again, we should be getting used to this. I'm not saying it's simple, but you should be getting used to this. So this condition day will now be the oldest reservation of the sailor in new reservation.sid. Okay. That's, again, you should understand that, but that's actually right now not so important for triggers. The important thing is that when the sailor has made too many reservations, this trigger will take some action. Okay, and also don't worry about this exact syntax, referencing new row, referencing new table. So I'm not going to ask you to know this in detail, so I won't ask you to write triggers the way that we've been asking you to write queries. And the other reason not to worry about it so much is because it changes system to system, which is an unfortunate fact. So let's say we wanted to write a trigger that makes sure that no employee ID is less than 0. Okay, so if you used standard SQL syntax, you would use this type of syntax. So you'd say something like create trigger after insert on referencing new table. So this is the syntax that we've been looking at. By the way, this is a useful statement, rollback transaction. So within triggers, if you don't want to do something complicated like delete the oldest reservation, this is a good fallback. You can just say, okay, I found something funny that shouldn't have happened. Just revert to where you were before, and so the keywords for that are rollback transaction. Now SQL Server syntax here is just a bit different, and again you can see that it's similar. You can see it's implementing the same concepts, but it's just different enough to be confusing, right? So I have create trigger check range on employees. Okay, so it starts. It forces you to start with what table you're defining the trigger for. And then instead of saying after insert, it says for insert. You have this keyword as in there. Instead of when, it says if. Okay, so there are these kind of small differences, but they do mean that you cannot just take a trigger that you wrote in standard syntax and run it on SQL Server, and also you cannot take a trigger for SQL Server and run it on MySQL unless you're lucky. Okay, so there's different syntax is being used here for the same concepts. Okay, so triggers are, as you can see, very powerful. So in the first example where we inserted sailors into a new table, you can see that they can be used to log events, and that is one of the very common applications. So the trigger monitors for insertions, and then it writes information about what was inserted, and in effect producing a log. And you also see that triggers can be used to enforce very general constraints by saying, right, when, for example, when there's an insertion, check if there's a condition violated, and then maybe roll back the transaction or even take action to correct the condition, like in the delete reservation example. And so again, this is why most systems don't implement something like check and assert, because they would say, well, if that's what you're trying to do, just use a trigger. So let's talk a bit about how those various concepts compare. So triggers can be harder to understand than, say, assertion or check, partly because the syntax is more complicated, right? It's like, well, are you doing it after an event, before an event? Are you doing it based on a table, based on a row? With assertions and checks, you just write down the condition that you want. So this is a declarative approach, and you let the system enforce it. Several triggers can be activated, as I was discussing. That's called chain activation. So then it can really be quite complicated to think through what these things are doing, what their effect may be. Another issue is triggers are more like general programs. So a database system, it's hard for the database system to just kind of inspect a trigger and optimize it. So with assertion, for example, remember our sailors and boat example we were adding, and from adding number of sailors, number of boats, the database system can scan that and say, oh, okay, this is only about sailors and boats. So if I have 50 other tables in my database, I can ignore those. With a trigger, it's harder for the system to see which tables exactly are involved, especially with chain activation. So usually there's very little optimization possible. Then, as I mentioned, you can use a trigger to log events, and more generally, they're used not only to enforce constraints, but to sort of monitor the database in general. So for a while, actually, triggers were very fashionable. There was a lot of talk about active databases, but now there are all these concerns about understanding their effects, understanding interaction, so people are sort of scaling back their use. And as I also mentioned, practical database systems actually quite limit what you can do, especially when you're trying to cross-reference different tables. I mean, MySQL pretty much does not allow a trigger to delete records, for example. But nonetheless, it's a useful, powerful concept, and if you want to enforce an integrity constraint and you're having trouble doing that with check, probably a trigger will do it for you. Okay, let's summarize. So SQL supports many integrity constraints, checks and assertions we've seen. The idea with check constraints is that they're associated with a table, a single table, so they're activated only when that table is modified. Assertions may be activated, may involve several tables, and may be activated when any of those are modified. Database administrators have to choose which integrity constraints to what the most appropriate method is. Oh, and I also should have said many of the constraints that we discussed in ER diagrams, for example, participation constraints that we cannot express using primary foreign keys, could be expressed using triggers. Okay. Okay, so that's it for today. Okay, I hope this was a good substitute for my own presence here. So Zensong can take more questions about the lecture, and also he's got information about the midterm, which is also posted on the website, and he can answer questions about content. So if there are some queries you didn't understand or something you didn't understand that will be on the midterm, you can ask him to explain it. And same with assignment 1, assignment 2. This is a time when we can basically review anything that you feel you need to have clarified before the midterm. And then I will be back for the midterm on Thursday and be handing that out and supervising the exam myself. And again, the plan for the midterm is we start at 2:30. Don't forget to bring your ID. Midterm will run for 2 hours, so until 4:30. Then we'll have a bit of a break so everyone can recover from the effort. And we're going to have a lecture where we start the next topic, which will be programming with SQL. Okay, so see you on Thursday.